Hi, this is Srija. I am from CSD C-section department. Today our topic is about floppy disk data transfer techniques from the subject computer organization and architecture. So to learn more about floppy disk data transfer techniques, we have to enter into our slides. So the next slide is okay. Now the next slide is about the introduction to floppy disk data transfer techniques. Here, floppy disks were a popular storage medium in the late 20th century. Data transfer techniques were developed to efficiently read and write data on floppy disks. These techniques allowed for reliable data transfer between computers and floppy disks. Here, we can see the image of the floppy disk data transfer. So, to learn more about the floppy disk data transfer, so let's enter into our next slides. Now, this slide is containing about magnetic recording on floppy disks. Floppy disks use magnetic recording to store data. Magnetic particles on the disk surface hold binary data in the form of magnetic charges. Read or write heads in the floppy disk drive interact with these particles to transfer data. So, if you observe this particular image, we have um, the the floppy disk. If you observe this image, in this image we have the parts of the floppy disk. The parts are the HD hole and the right project hole. One is case and another one is liner non-woven and another part is hub and the next part is magnetic disk and another one more part is also belongs to liner non-woven, and we have the shutter and the wiper tab and the write protect. We have these parts in the floppy disks. So our next slide is about data encoding techniques. Data on floppy disks is encoded using various techniques for efficient storage and retrieval. We have FM. All we know about the FM, it's about frequency modulation. Encoding is commonly used on 3.5 floppy disks. MFM, modified frequency modulation. Encoding is used on 5.25 floppy disks. As we observe this image, we have data and computer communications, data encoding. We have the introduction as either form of data can be encouraged or either form of signal. So this is about data encoding techniques. We have two techniques, FM and MFM. So after this, our next slide is about the track and sector organization. Floppy disks are divided into tracks, which are concentric circles on the disk surface. Each track is further divided into sectors, which are pie-shaped sections. The track and sector organization allows for easy access and retrieval of data. So, as you observe the image, you can understand more easily how the track and sector organization was there. We have up to 39 tracks we have in this disk. The side 0 is equals to bottom side, and we have side 1, it is top side. Actually, it consists of 40 tracks and double sized 360K flow. We have 9 sectors and one index hole and 40 tracks. And next we have read and write options. During a read operation, the floppy drive's read head detects the magnetic charges on the disk surface. These charges are then converted into binary data and transferred to the computer. Write operations involve converting binary data into magnetic charges and writing them onto the disk. Also, we have an image here how it is constructed. We have a question also. A disk drive is a position control system in which a read or write head is positioned over a magnetic disk. The system responds to a command from a computer to position itself at a particular track on the disk. A physical representation of the system and a block diagram are shown below. The options are: find k to yield a settling time of 0.1 second. What is the resulting percent overshoot? What is the range of k that keeps the system stable? If you watch this image, we have magnetic disk, position sensor, and motor, and etc. controller. And in this slide, we have about the error detection and correction. Floppy disk data transfer techniques incorporate error detection and correction mechanisms. Techniques like CRC, the full form of CRC is cyclic redundancy check, are used to detect and correct errors in transferred data. These mechanisms ensure data integrity and reduce the risk of data corruption. So the classification, if we see the classification, error detection and correction. In this we have two methods, error detection techniques and one more is error correction techniques. From that, error detection techniques was divided into four parts. The first part is about simple parity check, and the second one is two-dimensional parity check, and the third one is checksum, and the fourth one is cyclic redundancy check. And in error correction techniques, we have one more classification, that is Hamming code. So this is the classification of error detection and correction. So if we enter into our next slide, so now we have interfacing with the floppy drivers. Computers interface with floppy drivers using various protocols such as IDE, SCSI, or USB. Different connection types such as ribbon cables or USB ports allow for data transfer between the computer and the floppy drive. These interfaces provide the necessary communication channels for data exchange. The image is about the floppy drivers. If you see this, you can come to and understand that how the floppy drivers is going to be look like. So our next slide is about file systems and formatting. Floppy disks require a file system for organizing and managing data. Common file systems used on floppy disks include FAT12, FAT12 and FAT16. Formatting a floppy disk prepares the disk for data storage by creating a file system and necessary data structures. We have two low level formatting. In that low level formatting, we have two options like floppy disks and hard disks. We can see the images of floppy disk and images of a hard disk also. So this is about the file systems and their formats. So if we go for our next slide, we have the information about floppy disk capacity and its limitations. Floppy disks come in different sizes, such as 3.5 and 5.25, with varying storage capacities. 3.5 disks can typically store 1.44 MB of data, while 5.25 disks have a capacity of 360 KB or 1.2 MB. Floppy disks have limitations in terms of data transfer, speed, and susceptibility to physical damage. If we observe these images, we can see a 8 inches of a floppy disk and 5.25 inches, and next one is 3.50 inches. So these are the capacity and limitations. And another slide is about legacy and modern alternatives. Floppy disks have become obsolete in modern computing due to advancements in storage technology. Legacy systems may still rely on floppy disks for data transfer and compatibility. Modern alternatives such as USB flash drivers and cloud storage offer faster, more reliable data transfer options. We have note also here. This is a sample presentation outline and should be further expanded upon and customized according to specific requirements. So this is about the legacy and modern alternatives. So I hope you understand about the floppy disks management systems. Thank you.